Hello, and welcome back to my channel. My name is Jeffrey Schultz, and I am a master's student attending Concordia University, Chicago, studying computer science. In this video, I'll be discussing Bash power tools, some commands we see with them, and then I will be giving a live demonstration of all the different topics in the Mac terminal. But before I continue, if you have not watched my previous two videos on Bash scripting, or if you have not watched my previous series on Linux, I highly recommend you watch those before you continue on with this one. But before I do that, let's begin. So Bash power tools, some topics and commands. So the first topic is going to be called special variables, and some examples of these are $!! Hashtag, $@, and $!? And you're going to be seeing exactly how these are used in the live demonstration. So the next command is called trap. So all you really do is you use the word trap, and it just you use the commands and for signals. Let's say, for example, you would say trap on whatever command you want to do. So let's say remove, you're removing a temporary file, and you just say exit, and exit is the one keyword that is going to help trigger this. So the next one is called file testing operators. So we have three different ones. We have -e, which means exists, -w means a file is writable, and -d is for a directory. So the next one is called getopts, and this is just used for parsing command line options and scripts, and you use arguments with these. So you're going to see how these are used in the demonstration. So moving on, we have pipelines, and all you do is you use a vertical line to pass output between commands, and this is something that I previously covered in my Linux series, so this is going to be, it's used very similarly in Bash scripting. So next up is process substitution. You either have less than or greater than with whatever command for comparing or redirecting outputs. And I also covered this briefly in my Linux series. It's expressed a little bit differently, but the logic is the same. So regular expressions, pattern matching with, you use double square brackets with string and then it equals whatever with the rejects. So it's just for comparing strings. It matches patterns using that syntax you see right there. Then some other commands that we're going to be going over are grep, which is being able to search, and this is something I also covered in my Linux series. Sed, which is for transforming. AWK is for analyzing, and for organizing, we use the sort command. So I'll now be going through all these topics and creating various scripts for each of them, so I'll see you guys in the terminal. Actually implement all of these different topics that we just went over. So the first one we did was called special variables, and what the first topic we're going to do, we're going to create a background job, and we're going to use $! To be able to find the PID of it. So what we're going to do, we're going to create a file called nano background PID, and remember it's got to be a .sh extension for all of these for Bash scripting. So we're going to create that, and we're going to write our script now. We are going to say #! /bin /bash, and if you watch my previous series on Linux, this line here has to go at the beginning of every Bash scripting file. It is absolutely mandatory. So what we're going to do, we're going to write sleep5, and we're going to put the and then we're going to say echo background job PID with a colon, then we're going to say $! Then we're going to say wait, we're going to say echo job completed. Just like this, and we're going to save it, Control-X, you hit Y for yes to save, and hit enter. We're going to add the execute permission using chmod +X to background PID .sh. So what we're going to do, we're now going to execute it, /background in the file name, background PID.sh. So as you can see, it's going to show me my background job PID, 95,443. And as you can see, after 5 seconds, which is what that sleep5 does, if we're going to type in sleep5, sleep 10, sleep 15, it tells the computer to wait a respective amount of seconds, and that was what our wait command did. And wait said wait, and then once it's finished, print out job completed. So that is how we would go about doing this. So some common errors that people actually make with these are forgetting to put the and symbol, and then otherwise it's not going to work. It's going to the job is going to run in foreground. This is not what we want. And also they just don't wait long enough. They don't wait that 5 seconds, even though they put the sleep there and they said you want to wait before you print out job completed. They don't simply wait long enough, and the job still might be running when the script ends, and this line here would never print, and the job would be all messed up. Okay, so I'm going to clear the screen. We're going to move on to the next task, which is going to use the $! And the $@, and you're going to see how that works. We're going to create a file called we're going to use nano. We're going to create a file called count args.sh. So then we are going to say #! /bin /bash, just like that. We're going to say echo, and we are going to say number of arguments we are going to say $, hashtag. And then the next line is going to be echo. We're going to say number. Just arguments, and we're going to say $at. So just like this, we're going to save it. We're going to add the execute permission, chmod plus x, to count args.sh, and then we are going to say executed count args.sh, and we are going to provide the arguments. So we're going to say apple, banana, and cherry. So something like this. As you can see, it prints out the number of arguments. So that is what the hashtag, the $hashtag does. And the actual arguments, it takes the actual arguments that we provided right here in the command line while we executed this file. And the $at is going to provide all the arguments we provided. So that is this one. So some common errors that people make with this one is they run it with no arguments. They'll just run something like this. They'll just type in count args.sh. And yes, this is a correct way of executing a file, but when it is relying on arguments, this is not going to be correct. It will output absolutely nothing if you do something like this. And sometimes people will do the $1 like this instead of doing the $at. What we want to do is the $at just like this. But people will sometimes they'll do this one, and this is only going to output the first argument and not all of them. It is really important to do the $at in this case. So I'm going to clear my screen. We're going to move on to the last task already in this special variable section. So we're going to create a file called nano. We're going to say exit status .sh. And we're going to say hashtag exclamation point, /bin, /bash. We're going to say ls non-existent. There we go. We're going to say echo exit status of failed command. And we're going to say $? And we're going to say ls / echo again. We're going to say exit status of successful command, and we're going to say $x ? Again. Save this file, add the execute permission to it, chmod plus x, exit status .sh, and then we're going to execute exit status .sh. Like this, and as you can see, non-existent, no such file or directory, exit status of failed command, there was one. So this worked properly, and this is what we wanted it to do. And then exit status of successful command, there were absolutely none. We had one unsuccessful and one successful because non-existent quite literally just does not exist. So common errors that people make, or they'll be able to check the $? Too late. It's going to be overwritten by another command, and that's it. So this is the end of the first topic. So I will see you guys for topic 2 in a second, which is going to cover the bash trap. Was the bash trap command. So the first task we're going to do is create a cleanup temporary file using Control-C. So what we're going to do is create a file called nano. We're going to call it trap cleanup.sh. We're going to write the following script: hashtag exclamation point, /bin, /bash. We're going to say temp file equals temp.txt. And this is really important to remember. If we're creating a variable like this, we don't want any spaces, so it's got to be written just like this. We're going to say touch $, temp file, just like that. We're going to say echo created temp file. And then we're going to say trap echo, we're going to put this in quotes, echo, we're going to say caught Control plus C, then we're going to put in end quote, put a colon here, we're going to say rm-f $temp file, colon again, we're going to put exit, close the quotes, and we're going to say SIGINT. This is really important to do this because otherwise it's not going to work. People forget to do this. You have to do this. So we're going to say while true do sleep 1, and then we're going to say done. So save this file. We're going to do chmod plus x to this trap cleanup.sh, and we're going to execute it. So created temporary.txt using the variable. And we wait a second. And then as you see, as I hit Control-C right there, it pulls up caught Control-C right there. So that is correct. So people forget to press Control-C, and as you see, if I don't do that, it's not going to trigger the trap. As you see, it waited a second before I did it. That's what I wanted to show while doing that. And people forget to use the wrong signal name. You must use SIGINT, this one just like this. So we're going to clear the screen and move on to the next task, which is going to be trapping exit for farewell. So we're going to create a new file, nano. We're going to call it trap exit.sh, and we're going to say hashtag exclamation point \bin \bash. We're going to say trap. We're going to say echo goodbye, just like this. Close that and close the other quotes, and then we're going to say exit. This is really important to do this. We're going to say echo working, just like that, and we're going to say sleep for 2, which is going to be 2 seconds. So we're going to save this. We're going to add the execute permission, chmod +x, trap exit.sh, and we are going to execute it. /trap exit.sh, working. And there we go. After 2 seconds, it says goodbye. So there we go. So usually the one common error that people make is they're going to put a typo in exit, or they're just going to forget to put it at all. And this is going to, as you see, if we don't put this, the trap just does not trigger. So that is all for this topic. I will see you guys in the next topic, which is going to be for file testing. The next topic was file testing. So what we're going to do, we're going to check if a file exists and if it's writable. So we're going to create a file called nano. We're going to call it checkfile.sh, and we are going to write the following script: hashtag exclamation point \bin \bash. We're going to say if. We're going to use the double brackets here. We're going to say -f and then $1 in quotes. This is really important. We're going to say double and. We are going to say -w. So this is writable. We're going to say $1, just like that in quotes, and we're going to close this, put a colon, and then we're going to say then. We're going to indent a little bit. We're going to say echo $1 exists and is writable. So then we're going to say else, and then indent again. We're going to say echo. One more indent. Echo $1, which is going to be the first argument. Remember, this is not $1. Does not exist or is not writable, just like this. And then to end out an if statement, if you remember from my last series, we're going to just type in fi, save this file. We're going to add the chmod permission, change mode. We're going to add the execute permission, check file.sh, and we are going to now create a file called touchmyfile.txt, because we're obviously checking to see if a file exists. And then we are going to say chmod. We're going to add the permission to this. We're going to say u+w for this file, myfile.txt. And then we are going to say execute the file. We're going to say check file. We're going to execute the check file, .sh, and we're going to check it for the myfile.txt. As you can see, myfile.txt exists and is writable because I added the appropriate permissions. So some common errors that people will make with something like this is that the file just won't exist. They'll completely forget to create the file, and that's understandable because usually we create the file, we add the execute, and just execute the file. You don't usually do this, but with something like this, when we're checking to see if a file does something, it's going to be really important that we do this. And otherwise, if you do remember to do this, sometimes people just add the wrong permissions. This one's really important because this is going to add it for the user, and it's going to add their right permission. So as you see, it exists because we created it, and it is writable because we added the appropriate permission for the user, which is the U. So let's clear this and go on to the next task, which is going to see if check of a path is a directory. So we're going to create a file called nano check directory.sh, and we are going to say hashtag exclamation point \bin \bash. We're going to say if again, same syntax. Not of. If, just like this. -d, because this is for directory, remember. $1 in quotes. Close this, and we're going to say then. We're going to indent again, and we're going to say echo $1 is a directory. Put that in quotes, and we're going to say else. Indent again, we're going to say echo $1 is not a directory, quite simply. And we're going to say phi because we're closing up this. Save this file. And we are going to say chmod +x check directory .sh. And as you can guess, because we're making a directory, we're going to make a directory because we're checking for it. We're going to say mkdir testdir, which we're going to name that directory, and we're going to execute this file. Check directory, and we're going to say .sh, and then we're going to say for testdir. And as you can see, testdir is a directory. So there we go. So some errors people make, they'll completely forget to make the directory is one of them, and the other one is they'll maybe provide a file instead of a directory. Because remember, a directory and a file is not the same thing. A directory can contain files, but it is not a file itself. It is just a folder. So that is both of the tasks for this topic. I will see you guys in the next topic, which is input parameter parsing. Next topic was input parameter parsing, and I actually have these scripts ready because I want to go through them very carefully because these are a little bit more complex, but we are going to go through them line by line. So the first task was parsing -n and -a. So we're going to open the file using nano. I called it parse options.sh. So as you can see, I have the same line at the beginning of everything, #! /bin /bash. So what we do is we're going to say while get options, we're going to say n:\a because these are the two things we're going to be doing, name and age. We're going to say opt, and we're going to be calling this a variable. This is a variable. We're going to say do. We're going to create a case with the $sign with the respect to the variable we just created, op opt right there. We're going to say n with the close parentheses, and we're going to say name equals $sign op target. So this is like an option target or an option argument as they call it. So we're going to say the same thing for age, option argument. So age uses n and a. And as you can remember, no spaces, just like this with the variables. And at the end of this, the syntax is to just put a space and then 2 semicolons at the end of each. So then for the asterisk, which means it can mean all, we're just going to say echo usage. We're going to say $0, which is going to be an argument. We're going to just run it, but we're going to put in -n, which is the name that we created right here, and -a is the age, which is right here, the same variable we created. We're going to put a colon there, and then exit 1, and then another space, and with colon. So the same concept as these. So to close this case out, we type in esac, which is like just it's kind of like closing out an if statement with phi, same concept. And then we say done. So then I just added this because sometimes Mac is a little bit weird with this, and I wanted to add this because this is really important to do. Show what getOps parsed. So just to make sure that this works correctly, you want to be able to just debug. So I just said echo debug and make sure that the name matches up with the variable and the age matches up with its variable. So let me say if -z name and age for both of them, we're going to say then echo, or it's going to print out an error, and it's going to say both name and age are required. And we're going to redo this just like we did right here. We're going to say echo just like we did here. So when we put in the argument, we say exit 1, which is just what we did here. So it's really just rewriting this line right here again, just while it's debugging. But I'm adding this line to make sure that both of them are required while it's debugging. And then to close out the if statement, we have phi. So then I say echo name and name, ages name and age, just respectively. So we close this out. We add the chmod +x parse. I think I already did this, but I want to make sure. .sh. Okay, I did not. And then we're going to execute it. We're going to say parse ops.sh. We're going to say -n, which is my name, and then -a, which is my age. I'm 23. So let's do this. And as you see, the debug worked properly. It matched up both of them. And then my name printed out and my age printed out. So there we go. So some common errors that people make with this, so they'll completely forget to omit the argument, so they'll just type something like this. And I mean, again, this is technically correct, but when something's relying on a command line input, we have to put this there, or else it's not going to output anything. So the next task was menu-based get options. So this is going to be the same thing. I'm going to open up this file. I named it menu options.sh. So what we do is we create a function, and I went over how to do this in my first bash scripting video. So this is something that you guys should have seen. So show usage, we're going to say echo and exit 1. So it's really just the same thing, just in a function, -n for name, -a for age, using the usage, which is the same line here. Just a little bit different of syntax. We're using the little like angle brackets instead of the $signs. We're using the $signs later on though, right here, which is the same thing. We're going to initialize it as empty because there's nothing in there until we put something in the command line. So while get options, this is the same syntax. So we just add a colon before here. For options, we say do, and we're going to do case name op target option argument and age option argument. We're going to say backslash question mark. So this is just like if there's an invalid option, this is just like handling a case. So this is making sure that everything is there. We're going to say show usage, which is what we named our function. We're going to say action or echo option minus op or option argument requires an argument, so it's going to run the function again, and we don't need to put parentheses. As you can notice, it's just the function name. So we close out the case with esac, and we close out the while with done, and then we create to make sure check both are provided. So this is kind of like that debug statement that we did in the last one. So we're going to say if minus z name or age with the $sign for the variables. We're going to say both of them are required and show usage, which is our function otherwise. So we close out the if statement with phi, and then the output echo name, and then echo age with the $signs for each of the respective variables. So it's going to really be the same thing. So what we're going to do, we are going to do this right here. We are going to just say, we're going to add the plus x, just like this, for the menu options. I think I might have already done this, but I want to make sure I did not. Okay. We're going to say dot slash menu options dot sh, say minus n with my name and my age again. So it's the same thing, but as you can see, it does it properly. And it's not going to print out the debug because I didn't say to print out the debug like I did in the first one. It's just really running through it and making sure that it is debugging it properly before I have my output. But as you can see, it worked perfectly fine. So that's going to be all for this topic. I will see you guys in the next topic, which is going to be pipelines. So I'll see you guys in a second. Then we're going to be doing a few tasks with these. So the first of them was the most used shell. So we're going to create a file called nano most shell.sh. And this is going to be a really basic script. This is literally going to be 2 lines. So we're going to use #! \bin \bash like this. And then we're going to say cut -d with the colon. And this is a directory, remember. -d is a directory. We're going to say -f7 just like this. We're going to say space /etc /password, and this is a file on your computer that you should have. It's very rare that the computer does not have this. So we're going to say sort. We're going to say uniq, which is unique -c. We're going to do another one, sort -nr, and then we're going to say head -1 just like this, and then it's going to be our entire script. We're going to save this file. And then we are going to add the execute permission to it. Change mode +x most shell.sh. And we are going to then execute it. And this does not require any arguments, so you just execute it like normal. As you can see, 119, this is going to be my most used shell. It's just called user bin false. It's just going to print out a directory and whatever it is. So this worked properly, because if it did not, it would not have printed out anything. So this is the most used shell that I have, bin number 119, user bin false, whatever that directory may be. That is obviously the one that I use the most, because it'll print out whatever you use for this. So, but it uses the etc /password file on your computer. And if that does not exist, this will not print. You will not have an output at all. But that is very rare. So let's clear the screen and move on to the next task, which is going to be counting lines, words, and characters. So we're going to create another file, nano. We're going to call it wc pipeline.sh. And we are going to do the same thing, same first line as always. We're going to say wc minus lwc. We're going to just say $1. So this is going to be the command that we need to use for counting line, words, and characters. Doing this, we're going to add the execute, as always, wc pipeline.sh. We're going to execute wc pipeline.sh, and we're going to just say myfile.txt. So as you can see, it prints out everything, lines, words, and characters. Myfile.txt is an empty file, so there are 0 lines, 0 words, and 0 characters, so respectively. So the only error that people will really make with this is that the file doesn't exist. I obviously have a file called myfile, and I purposely left it empty to demonstrate this. As you can see, there's nothing in there, or else it would print out how many lines, words, and characters are in this file. And again, this is one that relies on an argument, because if you don't put a file here, it's not going to print anything. You got to put a file name here for something. But if you don't have the file, you just create it using echo, or you can just create the file and leave it empty like I did, which is proven that it's empty using here, 0 lines, 0 words, 0 characters, which is 0, 0, 0. So that's all for this topic. The next topic is going to be process substitution, so I will be doing that next. Substitution. So the first thing we're going to be doing is comparing two strings, and I'm going to show you guys how you can do this. So the first thing we're going to do is we're going to create a file. We're going to call it nano compare strings.sh, and we're going to type in, it's literally a 2-line script. So hash exclamation point backslash bin backslash bash. We're going to say diff, which is this command. We're going to say this with the little less than symbol, I guess you could call it. And then we're going to say the same thing. We're going to say echo. We're going to say $2. And this is going to compare two different strings for us using echo. So what we're going to do, we're going to save this. We're going to add the execute permission to it, change mode plus x, compare strings.sh. So what we're going to do, we're going to do this, compare strings.sh. And again, this requires 2 arguments, and it's really important to do this. So we're going to say foo and bar. So what we're going to do, we're going to do this, and it's going to output this 1C1, and it's going to look something really weird like this. This is not a normal output, but this is correct. So what does this actually mean? So what diff does in the file that we did, it compares 2 files, but here those files are actually just the outputs of echo 1 and 2, which the variables, so foo and bar. So it sees file 1 has foo right here, and file 2 has bar. So 1C1, if you're wondering what this means, it means one line changed. So the little this here, this less than foo or whatever, it means the first file's line 1 is foo, and then the greater than bar just means that the second file's line 1 is bar. So that's what this means. That's all this really means. So it's a really trippy output, but it is correct. So one line has changed, but it goes file 1 and file 2, and this means one line has changed. So there's this one. So we're going to clear our screen. We're going to do nano. We're going to compare sorted files. We're going to do compare files.sh, same first line, backslash bin, backslash bash. We're going to say diff, and instead of echo, we're going to use sort here, but it's the same thing, so the same syntax. $1, and then less than, we're going to say sort, $2. Close that, parentheses and quotation marks, so save this. We are going to then say, add the execute chmod plus x compare files .sh, and then we are going to say compare files, add the underscore there, .sh, and we're going to just say file 1.txt and file 2.txt. So as you can see, this is again a really weird output. So what it's going to do, but it is correct. So what this means is going to compare, the diff command is going to compare the contents of 2 different files. So what it's going to see, line 1 exists in file 1, so this is Apple, but not in file 2. So it says 1D0. This is what it outputs when it sees line 1 in this, but not in the other. And I'll show you what this means in here. So then line 4 exists in file 2, which is elderberry, and I will show you the contents of both of these files in a second. So it says 1D, so it says 4A4, which is going to just be add line 4 in file 1 to match file 2, basically. So what we're going to do, I'm going to show you file 1 and file 2, and then we're going to carry on, and I will show you why this is correct. So as you see, if we add line 4 to file 1, it would carry over perfectly, banana, cherry, date, and elderberry. And as you can see, the first line apple is nowhere to be found in the second file, so there we go, 1D0 and 4A4, meaning elderberry and apple are not in the other file respectively. Elderberry is not in file 1, and apple is not in file 2. So I know it's a really weird output, but this is correct, I can assure you that, and this is exactly what this means. So the next topic I'm going to be doing is regular expressions, so I will see you guys in a second with that. The first one, I have these scripts ready, by the way. So the first thing we're going to be doing is validating the email. And like I said, these scripts are ready because they are a little bit more complex, but I promise you they're a lot easier than they look. So the first one we did is we're going to validate an email. So I called it nano validate email.sh. Okay, so the first line always remains the same. We have to add this at the beginning of every one. And what we do, we create a variable. So just the first variable, so the only variable here, $1. And we're going to say it's got to equal So anything from 0 through 9, A through Z, or period, underscore, percentage, whatever of these characters, so A through Z, small and lowercase, 0 through 9, and then we have to do an at symbol, so we have to do plus at, so anything here, literally any character, and then at, same thing, same pattern as this. Then we're going to say dot, and then whatever, so like .com, .org, .web, whatever you would, literally any extension here. So it's just checking for the at, the period, and the text, obviously, and it's going to say valid email if all of this matches. Otherwise, it will say invalid. So that is it. We're going to add the appropriate permissions, validate email, .sh, and we are going to execute it. So we're going to just say validate email .sh, and we're going to put in just a mock email. So I'm just going to say mock@example.com. So there we go, valid email. So I'm going to clear my screen. The next thing we're going to do is the phone number, and this one is also ready because it's a little bit, like I said, it's a little bit tricky, the formatting. It's actually, you'd think that the syntax was similar for these two because it's just checking for validity, following a pattern, but it is a little bit different for the phone number. Same logic, just a little bit different of a pattern. So we're going to do validate phone. I called it validate phone.sh, so the same line here. So we're going to say the phone is the first variable, the only variable here. So it's going to be if, we're going to use an if statement, so if and fee, obviously that goes hand in hand, that's how you close out an if statement, if, else, and fee. So the phone number is going to match this pattern, so the one is going to check that it's a US, so like 1773, or whatever, 312, whatever area code, and then it's got to be 0 through 9, so 3 digits, 0 through 9, and then a dash, and then the last one is going to be, let me go to the here. So as you can see, 0 through 9 here, 0 through 9, 0 through 9, and 0 through 9. So 4, so it's like 3, 3, and 4. So it's following a regular phone number pattern using the +1, which is the US country code. So we're going to save this file. Oop, I did not mean to do that. chmod +x. We're going to add the execute permissions, validate phone.sh. And then we're going to just say a phone number and make sure to put this, execute this, and then make sure to put this, because it's basically a string, in parentheses. So 1, 2, 3, 4, 5, 6, and then we're going to say 7890. And then there you go, valid US phone number. So there we go. So that is all for the regular expressions. The next task is going to be special commands, and I'm going to be doing 4 separate ones for that. So I will see you there in a second. There's 4 of them. There's grep, there is sed, there is awk, and there's sort. So we're going to be going through all 4 of them with an example. So the first one is going to be grep, and we're going to be using a keyword here. So we're going to call this nano grep keyword.sh, and then we're going to type in the following script: hashtag exclamation point, \bin, \bash, and then we're going to just say grep, and we're going to say keyword in parentheses because we're checking for one, and then we're going to say $1 in parentheses, just like this. Save this file. Ooh, I did not want to enable dictation. Save that. We're going to then add the execute permission to it. +x grep keyword.sh. We're going to say echo here because we're echoing a keyword here. This is a keyword test. We're going to type something like that, and we're going to say, put that in a file called myfile.txt. And then we are going to execute grep keyword.sh, and then we're going to just say myfile.txt. So as you can see, this is a keyword test. It prints out properly, so the test is successful. So the one error that people make with this is, you guessed it, the file does not exist. You got to make sure you have a file, and as you see, that's why we did echo to a file that already exists. I've created this file before. So it was an empty file, so this is the only thing that should be in there. Let's just make sure cat myfile.txt. As you can see, there's the only thing in there because it was empty before, so I left it empty purposely. And if you saw a little bit earlier in the video when I did this, when I did a little words, lines, and characters, it was 000 because this was empty. So now we see we added this line, it is the only thing in there. So this worked properly. So I'm going to clear my screen. The next command is called sed. So we're going to create another file, nano. We're going to call it sed replace.sh. Same first line as always. And we're going to type in sed '*s, and then we're going to say \foo \bar \g, and the quotes, and then we're going to put another quotes, $1, just like this. Save this, add the execute permission to it. Okay, and then the next thing we're going to do echo foo. We're going to add this to a file, to the same file, myfile.txt. We're going to say sed replace .sh, and then we're going to just say myfile.txt again. As you can see, it changes the foo to bar using the syntax that we saw right there. So the first one was foo, and then we said replace that with bar using this syntax right here. Foo bar, so it's just replacing it. And if you see the \-g, I did in my first few videos on this, I discussed what my \g does. It helps with replacement, but set is a really good command that you can use for this. Yeah, that's it. So as you can see, it successfully replaced foo with bar, because I typed in foo and I said replace it with bar. And when I executed it, it did that successfully, bar instead of foo. So the only common error is that people forget to just type in the right word or forget to type in an argument for the file, but it kind of just carries over. So the next task is actually going to be awk. So we're going to do a file called nano. We're going to say awk students.sh. So then we are going to do the same first line, \bin, \bash. And then we're going to say awk, the command is awk. We're going to say quote. We're going to do the curly brackets. So we're going to say print name, just like this. We're going to do a space, and then we're going to do another space, $1, space just like this. We're going to say score. Score, and then we are going to do space, $2, because this is the second argument. Do this. Close this, and then close this one. Then we're going to say $1 again, because this is our first argument. So that is it for this one. Save this file, add the execute permission to it, chmod +x awk students.sh. So we're going to say echo -e, because we need to put some arguments in there, and we need to put some, so it can output correctly. So I'm just going to put in my name, and then a makeup score. I'm just going to say 90, and I'm going to say \a new line. I'm going to make up another name. I'm just going to say, let's just say Ryan, and we're going to say 89. To do this, so we're going to put this in a file called student.txt. So just like that, and then we're going to output it, awk students.sh, and then we're going to do it for this file. Oh, I might have forgot to put a, let me take a look. Legal statement at source line 1. Nano. Oh, yep, I forgot to put quotes right here. I knew it. So there we go. We got to make sure to put the quotes there. So that's that one. And then this one. And then that one's good. Quotes there. And then we do not need a quote here. That's my fault. I put it in the wrong spot. So this should absolutely be correct now. So let's take a look. Let's execute it again. And as you can see, there we go. It's got my name and my score, and the name and score for both of them. So there we go. It worked properly. So again, a common error is the one I just made, forgetting to put quotes in the wrong spot, forgetting to put, making sure the file doesn't exist, making sure that the file is passing their argument. Those are definitely the most common errors. They kind of carry over for all of these. Sometimes you have the wrong field separator, like I did. You forget to put a comma, you forget to put quotes, you forget to put the curly brackets. Sometimes you put the wrong type of brackets. So I mean, there's an endless amount of errors, but those are just the most common ones. So the last task for this is going to be the sort command. So what we're going to do, we're going to create a sort. We're going to do numbers. Oop, I'm sorry, I forgot to put nano. Make sure to do that. Nano. Okay, same first line. Okay, and then the next thing we're going to do, we're going to literally type in one line, sort -nr. We're going to say $1, so just like this. So what this is going to do, we're going to add the change mode execute permission to the file. Okay, and then echo -e. going to say 3, then backslash n. And we're going to say 1 backslash n, and then 4. So just something like this. And then we're going to put this in a file called numbers.txt. We're going to say we're going to execute it. /sort numbers.sh, and we are going to do numbers.txt. So let me make sure that this is all good first. Got echo minus e, quotes, and make sure to put quotes around this. 3 backslash n, 1 backslash n4. That looks all good. So as you can see, there we go. 4, 3, 1. It puts them in reverse order because I put it in 3, 1, 4. It prints it 4, 3, 1. And that is exactly what the minus nr does. So it's going to sort them in nrs in descending order. So that's exactly what this does based on the variable names until it concludes the end of the file. So it worked properly. So that is actually covers all the topics. So that is everything. I will see you guys back in the slides for some key takeaways. Okay, so what did we really just see in this demo? This is going to be some key takeaways. So it's really in a consolidated manner. So you can kind of just see what we just did and just all in one. So we first looked at special variables, and this helps us manage jobs, arguments, and command status dynamically. Trap is essential for cleanup and managing script termination signals. You have different file testing and option parsing for improving robustness in your interaction. And being able to combine pipelines, process substitution, rejects, and type processing commands such as grep, sort, awk, and sed helps us unlock powerful scripting capabilities. So that's all I have for this video. I hope you guys enjoyed. I hope you guys learned something new. Be sure to like, comment, share, and subscribe to this YouTube channel, and have a great day.